Hello, my name is German Marin, and I'm going to show you use case number 1, as we call it, which is about how to measure the productivity of technicians in an automotive or machinery sector workshop. In a technical service workshop, one of the main objectives is to increase efficiency in production. This implies that, with the same number of technicians, a greater number of equipment can be repaired in the available time. Except in exceptional cases, working overtime can mean an additional cost of 20% per hour, and if it involves weekend work, up to an additional 100% per hour. In the workshops, the technician works with each piece of equipment with a document called a work order, where the identifier of the equipment, its name, and the start and end date and time of the work order, and the tasks to be performed on the equipment are listed. In the workshop, we have a set of cameras that are focused on monitoring the box or work area of each technician. Here, we see a screen from where the workshop locations and the cameras in each workshop are managed. The work boxes are delimited by a virtual polygon in each camera. With our solution, we will calculate the time the technician spends in the box or virtual polygon during the duration of the work order. On the screen, you see on the left hand different places or locations, and in each of these places several cameras. Each location has an associated agent, which is ultimately the piece of software responsible for retrieving the images from the different cameras and sending them to the cloud for processing. What is the technician's process in the workshop? Normally, the technician has a mobile app where they register the number of the work order, the tasks, and the start and end dates, etc. For demonstration purposes, we will not use a mobile app, but will do it directly on the administrator's webpage. Obviously, we have an API that allows the mobile app or the workshop's ERP to create this work order. Here we see the latest work order that begins at 1 hour and ends later. For the convenience of this demonstration, we will put the two dates at once. We will indicate the number of the work order, the identifier of the equipment we are working on, the technician's name, and save. Here, we also see the name of the camera that is focusing on the technician's box. What we are measuring here is the time of the technician, who is a person inside the box or virtual polygon. We could also measure other classes, such as the time of a vehicle, such as a truck or car, inside a virtual polygon or box. The measurement of the technician's time inside the polygon will be done in a time range of 1 minute, and we will repeat the measurement every minute from the start date and time until the end date and time of the work order. To make it clearer, if every 2 seconds we receive an image of the box, it is checked every 2 seconds that the technician is in the box, and after 1 minute, we know the number of seconds they were there. For example, a technician may have been there for 30 seconds in the 1 minute range, and this time will be displayed in a real-time graph and also recorded in a database so that later a report can be obtained in Microsoft Power BI. We also have the possibility to control on which days and times the boxes are monitored. For example, here we have from Monday to Sunday the monitoring schedules. Let's now see an example of monitoring where every 2 seconds the presence of a technician in the box is detected, and every 1 minute the time this technician was in the box is put on the graph. On the x-axis of the graph, you will see the jumps of 1 minute, and on the y-axis, the minutes accumulated in the box. Here we see that the camera is not yet sending information as the start date and time of the work order has not yet begun. Here you see that the camera is sending information to the cloud every 2 seconds. Here you see that the camera has already started sending information. Here I am, and you can see the polygon shaded in red, and a rectangle that we call bounding box that recognizes me as a person. You can see that the time we are interested in measuring is where the bounding box of the person intersects with the virtual polygon. That's why you can see the word inside on the left edge. The name of the polygon is also indicated. In this graph, you can see each minute the accumulated time that the person is inside the box in minutes. When the work order ends, the camera stops monitoring the box, and now we have, from the start of the work order to the end of the work order, the accumulated time of the technician in the box. This is the time the technician actually spent in the box. This time will always be less than the start and end time of the work order, i.e., we can now know what is the productive and non-productive time. With this information, we can better identify efficiency improvements, such as reviewing, for example, the tools used or how the process of obtaining spare parts for that work order is. What we saw earlier is the source of information for the business, for example, so that management control can see reports in Power BI. Here we see a very basic report, where we are seeing that for a specific work order, the utilization was 85%. That is, the time the technician was in the box divided by the declared duration of the work order is 85%. There are other reports that can be obtained that are of greater value, such as the utilization of each technician per week, per month. Also the percent of time that the technician had without assigned equipment or even profitability per square meter of the workshop. The possibilities of measurement are very wide, and the maximum potential is obtained by combining this information with other available in the ERP of technical service through Power BI reports. The monitoring of the technical service with camera and using Productivity Studio opens an opportunity for the improvement of productivity, since it no longer becomes a black box for management control. If you had to stick with one idea, I propose the following. From the perspective of Lean, minimizing technical service time is crucial to maximizing customer value by reducing downtime and waste, resulting in a better experience and higher customer satisfaction. Reduced technical service time also allows maintaining a constant and efficient workflow, improves operational flexibility, and strengthens customer reliability and trust. These factors are fundamental to optimizing operational efficiency and strengthening the competitive position of the company in the market. Thank you very much for your time, and I leave you my email in case you have any doubts and inquiries. Until another video.